Holding it, I hadn't recorded yet. All right, a polynomial function of degree n has at most n minus 1 local extrema and at most n zeros. This should not really be a new idea, but think about a quadratic. A quadratic is degree 2. So we know a parabola has at most one turning point, because it's one less. And we know that the quadratic has at most 2 zeros. It could be less, but at most 2 zeros. So if you had a degree 5 function, the most number of ups and downs it could have in the graph would be 4, and it could have at most 5 zeros. Okay?
Can we all say hi?
No.
1, 2, 3, and everybody's
So describe how to transform x cubed into 2 times x minus 3 cubed, and then sketch the graph and give the y-intercept. This is just a reminder that transformations still apply. We've done a lot with x squared. We haven't done a lot with x cubed. So do you remember what x cubed looks like? It's like I call it an S graph, even though it's really not an S graph. But it's my favorite odd function. Remember, worst case scenario, you can make an XY chart. And if you pick negative 1, 0, and 1, and you plugged it into f of x, you would get negative 1, 0, and 1. You might say, hey, that looks like a straight line. But remember, if you plug 2 in here, what will you get? 8, because 2 to the third is 8. So this goes up really fast, and it goes down really fast, right? When I was student teaching at Southmont, there was a teacher named Mr. Wyatt that rolled around this chair all the time. They called him Big. No, like in his room, he would roll it to the edge of the door and leave it there, so when he left his room, he could sit right back down when he came back. He was a pretty big guy.
If Darnell was a teacher.
The teachers, the students called him Big Daddy Wyatt. And they really meanly, because he never saw the back of his chair because he was always sitting in it, they would write inappropriate things right here on his chair in chalk, and he wouldn't ever see it. And I observed this class when I was student teaching, and like I saw this, I'm not going to tell you what it said here, but I was like, oh, he has no idea. No, it was just a sentence, but anyway, that's a lovely story for Aiden to hear later. So we can make an XY chart for this. We can also just use the transformations. That's what I hope you do. If I say x minus 3 inside the function, what's going to happen to my graph? It's going to go right 3, right? Inside the function is left and right. So it's going to move right 3, and what's the 2 outside going to do? It's going to stretch it. So that means it's going to look thinner than the other one. If you didn't know that, you should be able to pick some points. But even if you didn't know that, I hope that you would pick 3 as your first point, because you'd always want to pick what makes that go to 0, and you'll see that that does just equal 0 because it's moved over 3. And the stretch, normally I would go over 1, up 1 for this one, but since it's stretched by a factor of 2, what should happen is if I go over 1, I'm going to go up 2, and if I go back 1, I'm going to go down 2. So that little curve right there in the graph is going to be stretched out a little bit more. So it's going to look sort of like this. And again, you can make an XY chart. You could pick 2 here, and you should get negative 2. And if you pick 4 here, you should get positive 2. And you'd get the same graph, but I just wanted to kind of remind you about the transformations. The other thing it says is give the y-intercept. Well, the black graph is easy to give the y-intercept because it crosses at 0. But I just wanted to remind you algebraically, this doesn't look like it's going to cross the y-axis for a long time, but it will cross it. How could I find the y-intercept without having to make the graph? Plug in, what did that mean? Plug in 0 for x, because the y-intercept is when x equals 0. So if you just pick 0 for x and see what you get for y, that would be your y-intercept. So on this one, if I plug 0 in there, I would get 2 times negative 3 to the third. Order of operations, I'm going to do my exponents first. So that would be negative 27 times 2, which means that that's not going to cross the y-axis until negative 54. So just a little reminder that you can find x and y intercepts without a graph. Yes? Yes. Hi, Miss Price.
Hi, I left things in here that I need.
I thought he was gonna grab the calculators.
Do you need the other papers?
I think I left more things in here than I need, but I don't know where they are. Might be the word problem. It'd be this stack of papers right here.
All right, there you go.
I told you I left them in here. You doubted me. I drink no coffee.
One day he said, "Do you have a 5-hour energy I could have? Do you have any of those just laying around?" And I was like, "I do not." Okay, other thing that we want to know about polynomial functions, we want to remember the end behavior. And if you had me for a teacher last year, you should remember end behavior, right? They could either goes like this, or it goes like this, or it goes like this, or it goes like this, and I can dance really well in my chair here. It's all about whether it's an odd leading coefficient or an even leading coefficient, and whether it's positive or negative. So remember that your degree is the highest exponent. So that's what's even or odd. So the highest exponent in the problem. And if you think about our favorite functions, x squared and x cubed, you can use that to help you. So a good function to think about for odd is think about if you know what x cubed looks like. The kind of same thing applies for any odd functions. So the end behavior, if the leading coefficient is positive, so that's like the number in front, if that's positive, then the right side of the graph goes up, the left side of the graph goes down. So like the left side of your graph should have an arrow pointing down, the right side of your graph should have an arrow pointing up, and then whatever in the middle. The notation for that, we wrote out last year, hopefully we'll kind of come back to you. Remember that you can write as x goes to infinity, f of x goes to something, and then you have to put the answer there. And then for the left side, you say as x goes to negative infinity, f of x, which is y, goes to something. You remember doing that last year? Yeah. And so all that changes on these is what you put here. So this one I'm saying as x is getting bigger, so as I'm going on the right side of my graph, my y values are going up, so I'm going to say f of x goes to infinity. And as x goes to negative infinity, so that's the left side of my graph is going down, so it goes to negative infinity. And an odd function will always have arrows going in opposite direction. The only thing that's different is if your leading coefficient is negative, think about the transformation that flips it over the x-axis, so the arrows just flip. So now the left side of your graph goes up, and the right side of your graph goes down, which is helpful when you're making your graph. If the question says describe the end behavior, though, you have to write out the infinity stuff. And so again, I kind of pre-wrote these from second hour. I just left them there. I figured I was going to be running out of steam by the end of the day. No. I have to get my kid. And then he has swimming. And my other kid has soccer.
Yes.
Oh yeah, and people are taking their test after school. Which, right, I don't even know when the last day to take the test was, but obviously that deadline has been extended, so I hope sometime this week, like today, tomorrow, or Friday, you could retake it if you were planning to retake it last week. If not, like I'll extend that to Monday, but I feel like by Monday you should be able to do that. So on this one, it's just going to flip. So now the positive side is going to go to negative infinity, and the negative side is going to go to positive infinity. So you just got to make sure you can write that out. And then even functions are like x squared. Either both arrows point up, or if it's negative, both arrows point down. So if it's positive, both arrows point up. So I'm going to say infinity, infinity. And if the leading coefficient's negative, like negative x squared, both arrows point down, and they would both go to negative infinity. So I'll let you write that.
Would that be like?
Right, like the good old quadratic.
Pretty sure that's my favorite.
What's your favorite graph? Look at my
Mine's a
bruise
linear
from
graph.
my.
I just know these names so well.
That's-
What is on your other one?
That's the tape from the real IV. They had to do 4 times before they could get the IV in. Because I was a little dehydrated on Thursday because I felt so bad. Apparently I didn't drink enough water. So she tried here first and it didn't work. And then she tried here, my vein blew. And then she tried here. Well, she went and got someone else to do it. And the other lady tried here. And then that was the 4th try.
Oh my goodness.
It was the worst IV experience of my life.
Look at him and said, stop.
Well, I was dehydrated, and so they just couldn't get it to work. But then by that point, they knew they were doing surgery, so they wouldn't let me drink anyway. So, what are you gonna do? Okay, are we ready? It's good practice. Could you have done it faster, adding better than 4 tries?
More better.
More.
Oh. It still doesn't make sense.
Okay. Leave me alone. I'm tired. Okay, so tomorrow we're going to talk about this more. But here's another thing about zeros. If you have x to the n power where n is an integer, whether n is odd or even tells you whether or not your graph touches the x-axis at that 0 or crosses the x-axis. Again, we can think about x squared and x cubed to help us. So if it's even, think about x squared. If you graph y equals x squared, doesn't that just touch here at 0? It doesn't actually cross. It comes down and touches the x-axis and goes back up. That's true for any even exponent on your 0. So like x to the 4th or x to the 6th, it's only going to come down and touch. But if that's an odd degree on your 0, it will actually cross. And so think about, you could either think y equals x, or I like to think y equals x cubed. That's an odd number. We know that that crosses like this, right? And so it actually crosses through. Tomorrow we'll talk about more about what happens, like what's the difference between x to the 5th and x to the 3rd, or x to the 4th versus x to the 6th. And we'll talk about that tomorrow as we look at those, okay? All right, so today's pretty easy in that we got to talk about in behavior, and we're going to find the zeros. But today's zeros are going to be pretty easy to find because either they're going to be factored already for you, and if this is already factored, what would I do to find the zeros of this? Yeah, you just set each factor equal to 0, so they did the hard work. So what would the zeros be on this one?
1, -2,
Oh my gosh, if only it was all so easy, right? Mackenzie. Oh, okay, sorry. Bailey. Yeah, I just got the microphone hanging out right here. That's what I used to do back in the old days, have my little microphone right here.
I remember when you were like on skin one.
Yeah. I bought this one because, what's his name with his mono last year? Remember him? Austin. He complained when he came back. He was like, your microphone stinks. You should get a new microphone. And it was true. Like, there was, like, feedback. You're going to tell him that. I said. Anyway, he missed a lot of school, and then he complained about my microphone. And so then I ordered this one off Amazon, and it's much better.
I feel like you should have personalized puzzles so that you can just skip something.
I will. The other thing they want you to do is describe the in behavior. So when it's factored out like this, you have to think about what would the highest degree be, what would the leading coefficient be. Do you have to multiply it all out to see that? No, you just have to multiply the highest x in each one. So what would x times x times x be? X to the 3rd. So that would be the highest degree. So it doesn't matter what the rest is because that is what determines your in behavior. So is that even degree or odd degree? And does it have a positive leading coefficient or negative? Positive. Because if I multiply positive x times positive x times positive x, right? Then it's positive. And then this is where you have to know these rules. You have to know if it's odd degree and it's positive, then the positive side goes up, the negative side goes down. And you would have to write as x goes to infinity, f of x goes to infinity, and as x goes to negative infinity, f of x goes to negative infinity. Drawing the arrows does not count as credit if it says describes in behavior, okay?
For the infinity signs all look decent. It's usually 3/4 or half.
Why are you so sad?
Usually it's like 1 for me. I get 1 for 1. The rest.
What about number 3? What would the zeros of this be?
The other one's -1/2.
Negative 1/2, because I would subtract 1 and divide by 2, and positive 4. It doesn't matter that it has a 3 there because you could take the cube root of 0, which is still 0, which still works out, right?
Yeah.
That was a lot.
No, it wasn't. Like, I'm just saying if you do this equals 0, it doesn't matter that that 3's there because if you took the cube root of both sides, the cube root of 0 is still 0. We'll talk about tomorrow what that does to our graph, though. Chazzy's sleeping over there.
You really want to be
I'm not sleeping.
What about the degree of this one? What would the degree of this be if I multiplied it out?
5, 4,
32, 1.
6, x squared.
So what about this? This is x minus 4 to the third. So what would be the highest degree if I multiplied that out?
4.
This would be x to the third, and then times 2x would be 2x to the fourth, right? So you have to think about taking the powers, then multiplying it. Watch your signs if there's a negative in there. So now that we know it's 2x to the fourth, that's an even degree with a positive leading coefficient, so both arrows would be going up. Yes? So I would say as x goes to infinity, f of x goes to infinity, and as x goes to negative infinity, f of x goes to infinity. Yes? No? Maybe so?
I know.
What?
I keep putting commas after f of x. I don't
So
know.
you're just missing the like little.
Okay. I'm going to skip the next two because they're just the same thing. It just says describe it in behavior. But really quick, if you want to have it in your notes, this is even degree and positive. So I'm just going to draw the arrows on this one, even though on a test that wouldn't count, right? And what about on this one? They would both go down.
I don't know. I just assumed because that was yeah.
Odd.
Oh.
Oh,
So they're going to be opposite, but it's negative. So it should be the left side goes up, the right side goes down. Right? Like you need to study that chart if you don't know it.
wait, for the first one, the coefficient was 3.
Yes, but so the even or odd is the exponent, right? It's what is the highest exponent for even or odd. The leading coefficient is all about whether it's just positive or negative. Okay? Last thing. What if look, I saved this because I wrote it earlier. What if it says find the zeros of the function algebraically? Eventually, we're going to get back into all those PRZs where you have to check all the numbers. Remember that fun stuff? But right now, if I say solve algebraically, it really just means to factor, right? So could you factor something out on this one?
5x.
I factored out a 5x. And then if you factor out the 5x, can you factor what's left? I hope so. So then I factored like what multiplies to give me 2, that subtracts to give me -1. So I factored it into that. And now, is it like the other ones? Could you tell me the zeros of that? Voila. And so what I have for you is a little worksheet. This will be your homework that you're going to put with your book homework. Still recording.